This is the fourth lecture that I've recorded, and this is the lecture that takes us up to Tuesday, January 18th. It's important that you watch this by Tuesday, January 18th, because in this presentation, I'm going to give you an assignment that is due to me by email by 10 p.m. on January 18th. So if you watch this after January 18th, you would have gotten a 0 on a 5-point exercise. So it's important that you watch this and do the exercise before January 18th. Of course, if you watch this today, which is the 15th of January, you can send in the email right away. So I can receive these emails responding to this homework assignment anytime before 10 p.m. on the 18th of January. Okay, let's have a little fun. Up to this point in time, I've been trying to give you advice on how to study for this class and also other science classes. And just to reiterate the most important points, when you are studying, you have to be thorough. You have to make sure that you're studying everything you're studying that is going to be covered on a test. You have to do this on a regular basis, just like you'd practice a sport. You have to do this by yourself. You can't rely on others to quiz you and to be thorough. So I have some people tell me that someone else is going to quiz them. That isn't thorough. Doesn't meet this category right here. Further, relying on somebody else may not allow regular review. You may not be able to study on a regular basis because they're not available. And finally, you have to have a way of knowing what you know. You have to be able to quiz yourself in ways that are going to be like the test so that you know how you're doing, so that you identify what you know, and most importantly, amazingly, you have to identify what you don't know so then you can focus on that. That's where we've left off. I want to continue now talking a little bit more about effective study techniques, but actually bringing in some science now and starting to talk about some zoology. Humans and other animals have natural biological rhythms over a 24-hour period, and we call these circadian rhythms. Circadian rhythms, okay? What are examples? What are things that happen on a regular basis about the same time every day? Okay? And what I'd like you to do, if someone else in zoology is near you right now, or you can pause this and wait till they're around, the pair of you or more can try to think of 3 or more different aspects of your own biology that are examples of circadian rhythms. And if someone's around you who's not in zoology, it still would be fun to think about this. So we're talking about things that happen every day, typically about the same time that day, of the day. So something that maybe always happens at about 8 in the morning, or something that almost always happens about noon. Okay? So think of some examples and pause here to think of your own examples. All right, I hope you've had a chance to look and think about the different kinds of examples that might be in your life. Here are some that I've thought of, and you can see whether or not yours are included on this list. Sleep. I hope you would have guessed that right away. Something that you tend to do, I hope, on a regular basis, certainly on a school night. And when you had high school or elementary school, honestly, you were probably even more disciplined about that. It might be because a parent or other loved one was caring for you and urging you to go to sleep at a certain time. Of course, you had to wake up at a certain time, and maybe you woke up before the alarm clock went off because you had already developed a pattern in your sleep so that you woke up even before the alarm went off because you were ready to start your day, probably going to school. Hunger. Maybe after you wake up and get going, you'd like to eat something, you're hungry in the morning. Maybe you don't eat much in the morning for breakfast, and then maybe you're really hungry by lunchtime, whenever that is for you. I hope that you will have eaten at least breakfast or lunch, but I'm going to guess that sometime in the early evening you start to get hungry for dinner or supper, depending on however you call that. Here are other things that happen on a pretty regular basis. Urine output. So here's something fun to think about. Are there times of the day when you think, yeah, I am going to the bathroom, I'm urinating more at this time of the day than any other time of the day? And if that kind of occurs to you, it is usual that people have the highest urine output early in the morning, maybe about an hour or so after they've gotten up. So they start by urinating when you get up, and then they may have to urinate even more that exceeds anything that they've recently drank. Body temperature. So this is fun. I don't know if you know, but when is your body temperature the lowest? And the answer is that our body temperature typically, and of course there's lots of variation amongst people, and so there are exceptions to all of these. I'm talking about general patterns, and one of the most important things that you learn in zoology is that there aren't clear, fast rules about what organisms do. There are exceptions all the time. But typically, body temperature drops as we're sleeping, and in fact, a lower body temperature seems to be an important part of getting a good night's rest. So what some people do is allow the temperature in the room to drop. And you would find that when you wake up in the morning, before you get out of bed, that's when you have your lowest body temperature. Then throughout the day, your activity levels increase your body temperature so that you could have a fluctuating body temperature that's near your peaks throughout the day. If you have to walk across campus to come to a class, if you have to be very physically active for your job, or if you're in a sport and you're practicing or playing in some kind of contest. Body temperature fluctuates throughout the day but drops at night. When you have to sit on the toilet, when you have to defecate, this is pooping, is what we're talking about here. This, for some people, happens on a regular basis. And some people enjoy that. They like the fact that they have a certain time of the day when they have time set aside. They usually can manage their schedule and they can find time to go and feel better and relieve themselves and then sort of get that out of the way. And finally, the sixth example that I've brought for you is alertness. And then I say, why? Well, we were just talking about studying. And one of the questions I'm going to raise for you is, when in a day is the best time for you to study? When are you most alert? And if you're not alert, maybe there are other things that you can do. Maybe you can do a workout. Maybe you can watch some TV. Maybe you'll be visiting with others. Maybe you're going to eat meals or do laundry or other cleaning tasks. It would be nice if you could be aware of when in the course of a day you are most alert, and that's when you focus your studies. Isn't that smart? What I want to show you is the general result of actually lots of studies, but a study I learned about when I started college with Lincoln back in the 1850s. Actually, Lincoln didn't go to college, and he wouldn't have gone to college in the 1850s. He probably would have gone to college in the 1820s because he was born in 1809. So in any case, I was not born in 1809 or anywhere near that. So no, I didn't go to school with Lincoln. But when I was in school, I was in an honors program down at Carbondale, and I was in the university honors system, and I had to take special classes. And I had the chance in my freshman year to take a medical school class on biological rhythms. And it, in fact, at the time was the only med school that was teaching biological rhythms. And I think that's really, really neat. And it was lucky. And this is a study I learned about then. So here we go. They took about 50 people. They measured their alertness levels. We don't need to go into how they were measured. You just kind of have to trust me on that they were pretty accurate ways to measure alertness. And they measured their alertness throughout the day when they were awake, of course. In general, the people were healthy. They were eating regular meals. They were working the same kind of shift, let's say 8 a.m. to 5 p.m. with an hour off for lunch, and they were under very little stress. So their lives were pretty steady. And here's what we found about their collective alertness levels throughout the day. And I said collective because that would include exceptions. So this is the average. I'll spend some time on this chart because this is where you're going to need to spend a lot of time. I made this chart reflecting on what I remember and what I still am finding in the literature. And what I'm showing you on the left axis here is just a number scale that says, look, at the very top is high, the highest level of alertness, and at the very bottom is very low levels of alertness, and probably below 1, you'd probably be dead. Of interest, when you're sleeping here, and so here's time and the person's sleeping, looks like maybe from 11 p.m. to about 7 a.m. when they get up, and remember they're working from 8 to 5. Their sleeping is still got a 3, and that might surprise you. Alertness while sleeping is not 0 because people sense their environment as they sleep, and you may or may not know that people tend to incorporate into their dreams what they are experiencing as they are sleeping. So if there's lots of loud banging noises, there might be loud banging noises in your sleep. If you're cold, you may be cold in your dreams. All kinds of other things. Smells could even be incorporated. So people have kind of a steady level, we'll say, while they're sleeping. And then they wake up and they go to work. And what we see is that there's a climbing level of alertness that tends to peak somewhere between 10 and 11 a.m. in the morning for people on this kind of time schedule where they're sleeping when they're sleeping. So they have breakfast, they go to work, and their alertness level rises. And now, as it approaches lunch, it starts to fall. Even before lunch, it starts to fall. Then you have lunch, and it continues to fall until an afternoon low of close to about 2 p.m. And then, interestingly, it starts to climb in very late afternoon to early evening with another peak somewhere at around 7 p.m. I don't mean to be too precise here because this is a generalization of what people are doing. And notice that the evening peak here is higher than the mid-morning peak. So a peak in the morning, a trough or a low level of alertness in the afternoon, and then a higher peak in the evening. Okay. Maybe you've noticed this in yourself. Okay, so a drowsiness in the afternoon. Just have to tell you this. When I first came to Blackburn College, I was teaching zoo in the fall. I was teaching a zoology in Olin Lecture Hall that had no air conditioning and had really old seats that didn't have any padding at all. And I had sometimes between 70 or 80 students all packed together in a hot auditorium. And guess what time the class was scheduled? The answer is 1:30. It started at 1:30 in the afternoon. So I just have to tell you, I don't believe I can make up worse circumstances for a class than hot, packed together, and in the middle of the afternoon right here. Zoology got shifted because, they don't give PhDs to monkeys. And I asked for the class to be shifted to about 11 in the morning. And look when lecture is, at 11 in the morning. And I wanted to use this kind of morning peak for my students. I didn't want to come in the evening. So in general, students peaked at about right here. And I found that engagement of students was much higher when the class was offered at 11 than when it was at 1:30 or so. So what we want to do is look at this pattern of alertness. And we want to wonder and speculate, which is what scientists do. We look at data and we go, what is causing this pattern? Okay. Now we're going to come back to this chart. I've got it repeated over and over here. For your homework assignment, what you are to do is to send an email to me, each person sending their own email writing out their own responses. You are not copying each other's emails and ideas. You write out your own ideas and try to be thorough. And you're going to formulate hypotheses to explain these data. What's happening here that's causing these two peaks and the afternoon lull? Okay. Now, hypotheses have to be testable. Maybe you learned that when you learned about science, but if we speculate on an explanation of anything and then you can't test it, well, then it has no use. You can't find out if it's true. Okay? But before we do that, I need to actually distinguish between two types of explanations in this regard. Now, this is not in your lecture outline. I'm adding something here. What these are proximate versus ultimate causes in evolution. So your hypothesis is more about proximate and not ultimate causes in evolution, okay? And here's the difference. So you got to understand this before you're going through the biological rhythms data. Proximate explanations are the mechanism. What causes something to happen? That is what we're asking for. Ultimate explanations are why it's adaptive. So why is it that organisms that responded this way were more likely to survive and reproduce, which is what natural selection favors? So I'll give you an example when it regards hunger. Why do we get hungry? The proximate explanation, the mechanism, is that you have low blood sugar levels. And low blood sugar levels are a sign that you haven't been eating much. And so that's the trigger of hunger, is low blood sugar. What's the ultimate, the adaptive, evolved explanation? Well, energy allows us to do stuff, and some of the stuff that you have to do as a species to stay around, to survive and reproduce, is to acquire energy. So this is an adaptive response to the environment because it helps you survive and reproduce, which is what you have to do if you're not going to be a species dying out, okay? So we're after the mechanism. What's the mechanism that's causing this data right here? What's causing this? So the homework assignment. This is a good slide, and I like having this recorded so you can come back to this and check again and see what Dr. Zelisko said. You're going to email me at my Blackburn address. The email must arrive by 10 p.m. on Tuesday, the 18th of January. It can arrive on Monday. It can arrive on Sunday. I'm sending this out on Saturday, January 15th, and you can send it today, January 15th, okay? If you wait until Tuesday evening, for whatever reason, maybe you procrastinated, and you have some technical issues that prevent that from coming to me, you're going to get a 0, okay? Here's the deal. If you wait near the deadline and then you have trouble meeting the deadline, well, you shouldn't have waited till near the deadline, okay? So smart people, people that get jobs, who arrive at interviews on time, people who catch planes and trains, arrive on time for the schedule, and they do so in a prepared way. So it's worth 5 points. It's not the end of your life, but I'm letting you know, if it doesn't arrive by 10 p.m., my time, then it's not going to count. Further, each of you sends your own email. There is no collective email from more than one person. And it has to be your own wording. And don't just write down a few words of an idea. I really want you to explain your idea. And remember, it needs to be testable. So if you think that you can think of something that causes this pattern, then we should be able to test that, maybe by removing the cause, okay? So you're offering hypotheses that explain the data, as much as the data as possible. So we saw really 3 things that we're trying to explain: a morning peak, an afternoon lull, and an evening peak that is even higher than the morning peak. If you can explain the afternoon lull, but you can't explain the morning and evening peak, well, then you would have only explained 1/3 of the data, and that's not it, okay? So let me show you another example. If your hypothesis is that the peaks are caused by the sun coming up, that would explain, rising sun makes us more alert, that would explain the morning increase. But it certainly would not explain the evening peak, would it? Because the sun did not just come up. So a rising sun hypothesis would not explain all the patterns. You can talk to all the other people you want, but for your email, it's only from you. It has to be your words and your expressions. Again, that email's got to arrive in my official Blackburn College email address in my mailbox by 10 p.m. on Tuesday, January 18th. Okay? And we will pick this up on the 19th. We will not have lecture, of course. We will not meet for lecture on Tuesday, January 18th.